Okay, yeah, sorry for the delay with the start this meeting. Welcome to today's session. As we discussed in sig-node, we are working on a new cap for resource plugin manager. We opened already some sort of fork for the cap. Currently under my GitHub. I will, Marlo, if you can put the link in the chat, I would appreciate. So we have some initial structure already inside that. I will most probably switch to the slides just to explain some of the motivation and so on. Right. Just. Currently our kind of observation about kubelet state was that we have several managers inside kubelet engaged in actual kind of resource management activities. In this illustration, you see topology manager, memory manager, CPU manager, device manager, and we know that also since 1.26 we will have a fifth one that will be the dynamic resource allocation. What becomes obvious in that illustration is already that if you want to extend CPU manager with some new vendor-specific logic, it's quite difficult kind of situation. And we as a vendor are interested to propose several kind of extensions, and most probably other vendors would like to do that too. So that's why we are thinking some sort of pluggable concept would be very good. We see pluggable concepts in kubelet already in the situation with device manager, also DRA, dynamic resource allocation, introduces the concept of drivers, which can be plugged from other vendors, other providers of such implementations. So basically what we were thinking, why not have a central point for all this? Basically we have one, the idea is if it's possible to have just one resource manager, which is responsible for handling of different pluggable concepts. It can be device plugins. It can be also dynamic resource allocation drivers. It can be also plugins for standard resources like CPU and memory. So our goal is if we can refactor the current state of kubelet so that we can have basically a single resource manager which can handle all this kind of pluggable concepts inside, allowing to minimize basically the complexity inside Kubernetes kubelet by having just single kind of entry point for pluggable work, and also allowing extension points for vendors, not only for devices, but also extension points for other resources which don't fit in the device sector or in the device field. And the commonality with previous approaches is there are some common points. The protocol basically can leverage a lot of the available mechanisms already in kubelet. Like it can function similar to device manager or to the dynamic resource allocation manager, where you have classical registration step. So basically there is a socket available on the file system, and resource plugins are also similarly to device plugins daemon sets which connect to that socket. and they get registered. After the registration, basically the lifetime loop of Kubelet kicks off, and we basically build a protocol which more or less invokes certain events on the daemon set. They can be admission events, or basically allocation events, or if basically we have to delete something, removing containers or pods. As this step is quite big, we think we were proposing if we should not consider doing it a little bit incrementally. So what we could do is build again a single point of contact resource manager, which handles plugins, and the existing managers, pluggable managers today, like device manager, and in this illustration not shown, dynamic resource allocation become children of this this central resource management component. And basically, if we have to handle device plugins, the calls will be forwarded to the device management component, and dynamic resource allocations, they can be forwarded also to dynamic resource allocation manager. This will allow us to do a small incremental step, basically, without and we can reuse completely the two pluggable components. For the other three managers, CPU manager, memory manager, topology manager, we are thinking to as we need to support existing functionality. One good approach is to offer a default plugin which will implement CPU manager, memory manager, and topology manager by reusing the existing code base. So those components will actually will be still residing in Kubelet as source code, but they will be instantiated, the managers will be instantiated in the plugin. So we don't need to duplicate code or inside a separate plugin. Yeah, so maybe I do a short break for questions if I'm not going too fast.
I had a question. Who maintains any state information across these plugins? Today, if I'm not mistaken, we have some type of checkpointing that tracks decisions that were made and things that are running. Are you delegating that to these plugins, or are you assuming that the Kubelet continues to maintain the checkpoint state?
The CPU manager plugins will, for example, this kind of legacy plugin, they still will maintain their own state. Like CPU manager will track what are the allocated CPUs, and if there are CPUs available. So this kind of there will be some sort of state handling inside the plugins. So it's expected to have that.
But in the former picture, I'm just trying to, it seems like the first picture you showed is your ideal picture. So I don't know if you're trying to get to that state, or if you're saying the next picture you show, which looks much different, is perfectly fine too. Like, is there how would I contrast these two?
To the two pictures, the contrast is that we have this device manager, and you will have the basically at the current point inside Kubelet, there are two managers which have plugin concepts. This is the device manager, and there is the dynamic resource allocation. And if you read through the link, I hope Mauro provided it, what we are thinking is some sort of abstraction or extension to dynamic resource allocation that it can handle those cases. Yeah, it would be really good if we can basically have a central abstraction which can handle dynamic resource allocation, can handle device management, and can handle standard resource plugins. This is more or less the vision, what we are after. And the difference here is that we start with a small step instead of implementing completely the functionality for device management inside this resource manager. We just delegate to the device manager the current existing device manager, and we make it a child of this resource manager. We somehow nest it inside, and we do the same for dynamic resource allocation, not shown on this illustration, but basically in first step, the big difference is we want to reuse those components. So the two paths basically for the device plugins and for dynamic resource allocation drivers, they will be handled by just passing the calls, the lifecycle calls, the needed lifecycle events to basically to those two children managers. In the ideal state, this gets merged inside the resource manager. Basically the functionality what device manager has and dynamic resource manager has, because if you look inside the code base, those three components, device manager, resource and dynamic resource allocation manager and resource manager, will have quite a lot of common ground.
Yeah, it's related to this specific point. So we're in the middle of iterating on a PR right now where at least the DRA manager is going to be moving outside of the container manager and directly inside the top level kubelet. At least for the time being, that's where it's going to be moving, because all the other managers right now, they are called during the pod admission loop.
Right.
We have a somewhat artificial restriction in the way DRA can do certain things right now because it's sitting inside the container manager. And to do away with those, we're temporarily pulling it up to the kubelet rather than having it nested inside the container manager, because we need to be able to have transient failures when we call out to we need to be able to handle transient failures if we happen to call out to the various device drivers that are connecting to it. And right now, there's no way to handle transient failures in the pod admission loop. If that call out to the plugin fails, you get a pod admission error. And so we could pull it back into the container manager and subsequently the resource manager as you're describing, but as a prerequisite to that, we would have to be able to add some mechanism to handle transient failures in the pod admission loop. So just something to keep in mind as we go to do this. If we want to support this the right way, that would be a prerequisite for that.
What do you mean by transient failures? Are you talking the device is just temporarily unavailable?
I mean, so in the device manager case, for example, if the device manager calls out to one of the device plugins and that call fails because maybe that device plugin has died or is unavailable for whatever reason, at present that will just appear as a pod admission failure, which is weird, but it is the way that it manifests at the moment. And with DRA, the possibility for these calls to fail is much higher. And so when we had it in this loop of the pod, just like we do with all the other managers. Sorry, my headphones just came out. So when we had it in this loop where it was, just alongside all of the other managers, we saw it failing quite often with these pod admission errors. And so we had to change the place that it's called into to not be in that loop. Yeah. So we'd prefer for it to be in the pod admission loop. It's just that we need to make the pod admission loop more robust to these types of failures if they can happen more frequently.
Yeah, one thing to note is that topology manager, it does currently fails, like you end up stuck in pending if the NUMA alignment isn't correct. So this may also solve that particular problem. So I think it's worth the cycles to figure it out.
See, in general, the point is very valid. Like we will have three things relying on plugins, having some sort of robust mechanism for failure of handling failures of plugin. It's really required. I agree on that.
Just to make sure I have a understanding here, are you proposing a kubelet is aware of one resource manager plugin in this picture, and we in tree have some default implementation of that maps existing function? Or are you implying that the kubelet would be aware of many resource manager plugins? Is it a 1-to-n or a 1-to-1?
More one-to-n. So you will have, let's say, a plugin which will be responsible, like in this case, for CPU memory topology. And then you will have plugins doing devices. And yeah, so you can have additionally further resource plugins doing further kind of activities.
Should a kubelet accept? So a lot of these other devices, the kubelet only advertises the resource when the plugin has registered to the kubelet. And it can only schedule the resource when the plugin is registered. And then there's like a heart beating type, are you still good? For things like CPU and memory, I'm assuming the kubelet shouldn't depend on the presence of that plugin to be able to schedule CPU and memory.
Correct.
But is there like a chicken and egg situation here that y'all have thought through on what one should do? Like today, at least I know I configure the kubelet, it's in one binary, and from the moment that kubelet starts, it can do what these resource managers do today. I'm assuming there's some latent type issues that happen here, like are these plugins deployed as daemon sets themselves that then need to be launched and managed by that kubelet that then can't have plugin decisions made on them? Or what are your thoughts on that space generally?
Derek, are you asking if it's like two levels of plugin? Like the resource manager has a device manager plugin, which then has device plugins attached to it?
I'm just asking, like today, traditionally the kubelet wouldn't be able to schedule a GPU, let's say, until a GPU plugin had registered, right? And then the kubelet advertised the GPU, and then, the pod says, I want a GPU, and the kubelet says, okay, I can do this. What I'm wondering is, absent a plugin, should the kubelet schedule any pod that requests CPU or memory? And then secondary to that, is the expectation that these plugins are themselves managed and deployed as daemon sets. And so I'm just curious if there's a particular issue here.
One option in the absent case is, of course, do default, which is more or less assign best effort class to any pod. So that's, even if you get guaranteed or something else, this is doable. You don't need
That doesn't seem right to me. What do you mean? I mean, I would assume I get what I asked for. But maybe to the macro question, are you imagining the kubelet is the manager of these plugins? Are these plugins deployed as pods?
Yeah. Basically, kubelet becomes the manager of these plugins, and you might have a small core which inside the resource manager, which can handle the case until when you don't have a plugin in the system, so that you just get best effort container or something, or pod basically. Another option how to deal with that is similar to core DNS. Basically, you start a pod at its through kubeadmin facilities, like with some default plugin, what we have. Right, but in any case, I think we will need some small core piece which does at least support a burstable class, a best effort class. of resources maintaining. Right.
All right, so I'm a little, I'll just, that one, I'm not so sure how I feel about that. I was just mostly trying to figure out if I just had the expectation right here, which is in the same way that many deployers in the world manage their CNI as a daemon set, and it would have some elevated priority class. And deployment of the CNI implies some readiness state about that node.
Right.
You don't have anything right now around deployment of these managers that could be used to imply some readiness state.
Yeah, it's also one option. We did not prototype such a solution, but if we identified it as needed, so we can take a look how to implement that.
So one of the use cases I know as a vendor is I have to be able to classify components that are quote unquote management on the node versus say workload, and things that are needed to support like the running of that node may need to get moved to particular CPUs in the particular set, right? And stuff classically for me as a vendor would mean that like I want my CNI on CPU 0 and 1. I want DNS plugin on CPU 0, 1. I want my metrics collector, you know, carved away. And I want to use the other 40 odd CPUs to run my 5G workload or that type of thing. So what I was trying to think through is in this world, how do I get to a spot where I could deploy in that fashion? Like at some level, the kubelet would want to make the plugin that decides how these things should run also be able to be supporting itself being boxed away, right? Like, and maybe I would want to make sure that this plugin is running before the other node daemons are deployed. And then I want to make sure I actually don't know what to do if this daemon is down around running the other workloads. Like, is there a dependency concept here? Because like in my head, when I think about like a 5G workload, and Swati and Francesco are probably aware of this now, like to me, it's like I've boxed away my management components into a very small budget, and then my workload components get the rest of the node, and they want the best alignments and stuff that they can get. And I appreciate that y'all are also interested in exploring other unique capabilities around your chipsets and stuff. But that basic use case, I still think is probably universal. And so I was just trying to think through like, how would we get to that? Particularly if these things are pods themselves. I don't have the answer in my head. I was just kind of vocalizing the things I think about when I look at this. And Swati or Francesco, do you see similar issues or have thoughts?
Yeah, I think Francesco and I were discussing earlier, the chicken and egg problem is definitely evident in this case. We'd have to figure out how do we bootstrap the system upfront. Maybe CNI, how CNI is doing it, that's something that we adopt, but I think it would have to be explicitly stated.
Right. I think you will need some sort of bootstrapping component. I agree. Most probably, ideally, in something through kubeadmin or something which deploys basically at least the default plugin. Right. So, and I like the idea for the ready state. It at least gives a clear picture if the node is usable or not. So I don't know what you think, the other people think about that, but it's not bad idea. Yeah.
There is Francesco here. There is another case which is related to what Derek and Swati mentioned, which is dear to me, and I think it's important for this forum, which is it's also about how we do manage the bootstrap. Because if the plugin which manages CPU goes in a crash loop, what next? I mean, is the node lost? Can the node recover somehow? So I just want to make sure that the failure scenario and the restart scenario is mentioned.
So, right, I was thinking today a little bit about also similar kind of issues. What happens when basically you have a dying plugin and stuff like that. Of course, changing the ready state of the node is a valid thing to do. Then I think you might be winning something if you think back to Kubelet today. If something happens with Kubelet and the container manager, or let's say CPU manager, topology manager crashes, you have most probably to reboot the whole thing. So you might be winning some benefits from bots, liveliness tests, stuff like that. I hope those can improve a little bit the situation what we have today.
But one thing to keep in mind while we look at this picture is I'm looking at this similar to the way we look at the Linux kernel and drivers. So basically what we're talking about here is a CPU driver. And what we're talking about potentially is a power driver, a memory driver, or a topology manager piece, which is kind of external to those drivers.
Yeah, I think that's all appreciated, Marlo. I think the issue is just, is it managed by the platform itself? And then what are the error cases when that is the case? Right? And
yeah, and I think where we're going is minimal management by the platform itself until the plugins are activated, and then you can take over. Those are definitely daemon sets, and we should be following other patterns already in Kubernetes. So I agree with everything you're saying here.
Yeah, so I just, I think for Francesco and Swati, the bootstrapping concern is probably very real. It would need to be able to box literally the first pods that are running on these nodes. I'm not sure in practice, maybe Francesco, you didn't get a chance to answer, what we have observed with like individual managers within a kubelet going unhealthy, and then the impact of that versus just, you know, restarting that kubelet. But I do imagine there's a sea of complexity that we would all uncover here around error scenarios. But maybe Francesco or Swati, you can speak to what maybe you have seen, if anything, there.
So one thing, go on, Francesco.
I just want to mention that it's totally true that a bug in CPU manager, for example, may cause the kubelet to crash. True, there is no discussion in that. The thing is, this remains true, and moving the complexity, actually, I mean, moving the CPU management, for example, and the memory management into a pluggable component makes the system complexity a bit higher. We gain something, but we lose something. So yes, a bug in memory manager, say, can crash the kubelet, and the node goes in a ready state. But at the same time, with the moving that on a plugin, if the plugin crashes, then we have more. I think we have a wider vulnerability surface. I'm not saying it's bad. I'm just saying it's different, and I think this area should be explored. And I'm done. The only thing I wanted to mention explicitly, because I think that bootstrapping a node could be, maybe I'm wrong, but could be somehow simpler than being able to recover a failing resource manager. This is at least my gut feeling. Yeah,
bootstrapping I don't expect to be as difficult as the faulty cases.
Yeah, I think this deserves discussion. Sorry, done. Gone.
Sorry, Francesca. And one thing to note is I don't think this is increasing complexity, because Kubelet is so complex as it is. And as we're looking at more and more things going into Kubelet to address specific things, this is actually simplifying our process going forward, and simplifying the Kubelet internally and moving that complexity into regular plugins. So if someone wants a very specific plugin that handles CPU resources in a particular way, and it's very specific to their case, the community no longer has to support it. You just have it in the plugin directory.
Yeah, so I agree. There's a difference between like community complexity and like deployment complexity. I'm hard pressed to not see more boxes and think more complexity and more error cases. So I agree there's a community relief here. I agree there's probably a differentiation that can be offered to users and vendors that it would be appetizing. I struggle to think that this will be as easy to deploy as present state, just because there's clearly more boxes and more error cases to think through. So, but I agree, Marlo, that there's definitely potentially a community relief valve here, but I'm not certain I'm convinced the deployment complexity is easier. And so I guess what I look at this here is, one, I agree that we can't drop existing function. There's people in the world depending on this. So if we move existing function that the community has taken on into one of these plugins, like that plugin needs to be as rock solid as the existing function today is.
Right.
And so from that spirit, I don't know if that plugin needs to run through a socket or can just be launched inside the existing kubelet today, so that people who don't need the additional capability don't take on the additional complexity. So I think there's things we can think about there, in the same way that we ran the CRI shim for Docker inside the kubelet today. Like, you could run a resource manager plugin to this new contract inside the kubelet. So I think there's things we should think through on that.
That could actually be bootstrapped as this kind of default plugin that they were mentioning.
Yeah, I was just trying to keep in mind that, like, in my head, like, we can't make people who are successful today more. We have to be cognizant of, like, the complexity we're asking them to take on with respect to their deployment postures. That there's probably things we could do just to vocalize here, that you could run a plugin in tree, also in process, and not regress anybody, but have a new contract for those who wanted to deploy externally. So yeah, I agree, Kevin. It could be one of those things we keep in the back of our mind.
If we ready to change topic a little bit, I want to reiterate on this checkpoint. I didn't get the answer where checkpointing will be happening, and also similar to checkpointing, where configuration do you think will leave an ideal picture? Is it something that we configure for kubelet? Is it something that we configure for a specific resource plugin? And how this, like, configuration will be versioned, if any? So ultimately, like, who controls what is configured? Is it the system admin that controls everything and Kubelet has no say into that, or it's opposite?
The plugin, or let me start with the state or the checkpointing. So if you think about checkpointing, I recall, for example, the CPU manager checkpointing, what cores it allocated in this kind of CPU manager state file. This can still happen. So you can, or the plugin which handles this, or implements the standard CPU manager, the default one, can still do basically the checkpointing, and then store the file in the as before, basically in var kubelet, basically, so that when something happens and you need to start from the checkpoint, this should be able to work as before. Right, at least from my observation so far, I saw this kind of checkpointing there. Maybe there's something more in device plugins and DRA, but for now, yeah.
DRA doesn't have them. DRA doesn't have any, but the device
checkpointing
plugin has a similar checkpointing to the CPU manager.
Right. So yeah, if it's only the CPU manager checkpoint what we have to deal with, we can leave it to the default plugin. Basically, the action, basically, to own it, to write to it, to read it, and stuff like that.
And what about configuration? Is it managers configured from kubelet, or there's separate configuration for every manager? Like, what is ideal picture? Like, who is in control?
Yeah, the control of daemon sets. So it's usually you can have most probably also some cluster light privileges, like what plugins can you install and stuff. There could be some configuration from administrator, what is allowed and what not to add as a plugin. But adding a plugin is similar to how you install a device plugin today. So, but
Okay. Carried with the plugin itself.
sorry.
Because so configuration of plugin carried with plugin itself. So it's
Right.
not like Kubelet will have, like today Kubelet have configuration. And I believe on one of the previous slides there was a situation when Kubelet config will be propagated down to plugins, and I'm not sure if it's just to satisfy current scenarios and support backward compatibility, or it's something that will stay
That
forever.
was in our prototype. We did such kind of solution, how we can share the kubelet configuration to a plugin. So yeah, basically after registration, we can send it to the plugin. So if you want to configure kubelet as before, it's also doable. You can keep the old kubelet configuration and pass it to the underlying plugins, but nothing stops us also to configure on plugin level.
So this is just temporary, or do you envision that plugins will need config long term?
This is open for discussion. I think you most probably will need some legacy solution on that, on the passing the kubelet config. But yeah, long term, you might switch completely to putting that as part of the plugin kind of spec, YAML spec.
Okay, thank you. And another question, I just, like for previous question, I was just wondering if you have specific scenarios in mind when Kubelet config will definitely be needed for plugins. If it's just for backward compatibility, I see that, okay, we probably need to configure plugins themselves.
Yeah, we were speaking about, or many use cases are usually relying that the system resources are separated. Like you have separated cores for runtime and stuff like that. Basically, the reserved CPUs, what are passed nowadays. So I think that this use case we see it in a lot of spaces, definitely also in telco space. So somehow we need to pass what will be the reserved CPUs and stuff like that for the kubelet and runtime. So this has to get to the plugin. Other configurations, in terms of plugin configurations, let's think about CPUs. A lot of people could have some knowledge, for example, that they have a workload which cannot tolerate having cyclic threads. You need full physical core allocations. So it's one option what you can configure also for the plugin. There or further, like huge page configurations, stuff like that, definitely fits inside very well.
Okay. And another question I had is, have you thought of possible abuse for these plugins? Like I remember somebody proposed to do plugins for pod admission, and those are plugins for pod admission. So people can register CPU, like fake CPU managers that will just check on some other parameters and wouldn't admit something because of it doesn't want it. So, is there some protection we can offer, or like
We can.
I don't know.
Yeah, no, very good point. It's one classical thing how we can protect it. We do some sort of handshaking, so the TLS certification basically checks if the plugin are actual plugins and not something strange. So I think also in the CAP description, what Marlo has, we were thinking it would be really great if we have some sort of community repo of such kind of approved plugins, or things which are, we know that are certified and so on, or basically cannot break your systems if you put them in.
Yeah, related. Do the plugins actually change any state about any running container on the node, or is it still ultimately the kubelet that is the one communicating to the runtime service to say, please make the state change?
So we
And then
both
independent of that, like what privilege do these plugins typically run with then in your mind?
in that to answer that, basically we would like to cover both situations. So we will have plugins which can run completely in user privilege mode, where you rely on the existing CRI interface, basically, or the resources what are to be allocated, they have to be fulfilled by the CRI interface, by the runtime service. But other customers, other users, they want more. So we think also for privileged plugins, which can do more kind of tuning, which is not covered by runtimes.
Yeah,
I mean, that's how the CPU manager works today, right? It modifies the set of CPUs
Right.
in the system containers that aren't actually running with exclusive CPUs. It grows and shrinks them based on what it's allocated to any other pod.
So we do that though by ultimately calling update container on the CRI.
Yeah, that's what it currently does.
Yeah.
No. So I guess what I was trying to figure out is, do you foresee any issue where the kubelet itself thinks it's the manager of a certain resource and you would want to cease it being the manager of that resource?
I don't think we will run in that issue, as we are tightly coupled with the lifetime loop of resources. So if we were, we are basically inside the loop, defining containers, updating containers, deleting containers. So we can avoid conflicts. Of course, some plugins which have privilege kind of mode, more or less, there's always the possibility that somebody provides a stupid implementation of the plugin, so we cannot avoid that, right? But nothing will stop you also if you have a privileged container somewhere in Kubernetes. Yeah, theoretically, you can break the whole system. So.
Yeah, I think Derek's question, I don't know if, Derek, I put words in your mouth. It's also about what kind of abuse can happen if if we allow that much of privilege. And abuse, not in terms of like hackers will hack into the system. It's more about people will try to use this plugin system for something that it's not intended to be used for. And then if it will become the generic pod admission plugin system, then we may design it as such, rather than like making people try to hack into it, and then they will hit some limitations or some side effects that we didn't intend for.
Yeah.
So,
Yeah, I think we have to cover that also, yes.
I mean, what I'm hoping will help is have a plugins group, just like the scheduler plugins have a kubelet plugins group, that there's blessed plugins, right? And then if vendors want their particular plugins, they can have their own blessing on them.
Yeah, so then related to this, existing efforts that people were exploring for topology aware scheduling, where would you see those efforts being redirected, modified, or adjusted in light of what you'd be proposing here?
Are you talking topology manager?
No, I'm talking about the efforts to make the cluster scheduler node topology aware, and the endpoint added to the kubelet to say, tell me the placement decisions that were made. And then the scheduler trying to
so this
take that into account when making cluster scheduling decisions.
Gotcha. So this is part of what we're hoping for DRA, because you not only have topology tied to things, you also have core type, core frequencies. If you start looking in sustainability space, your core frequencies do matter. So whether you're configured for high performance or lower performance cores. So these are all, to me, attributes about the resources that we don't have the ability to show today, but DRA does, which is part of why we want to piggyback on that.
I'm not sure if we're speaking past each other though. Just that there is an existing activity that folks were exploring to make the, let's just say, the high performance case, right, which is to reduce the amount of scheduling or pod admission errors that can occur with the existing plugin that are node side, to understand if there's even a slot that could fit this pod or not. Are you imagining that the kubelet is still aware of all these things, or are you imagining that these plugins would need to emit state that the cluster scheduler could rationalize or reconcile? And maybe Francesco or Swati, or I don't know, Kevin, I think you're working on the space some, could chime in more detail.
Yeah, long story short, very long story short, the requirement is just, quote unquote, to have something like the current incarnation of the pod resources API with some endpoint which at node level we can query to learn about the allocation. That's basically what we need to expose that at cluster level. I don't think, at this point in time, I'm not promising is all of it, but at this point in time, it seems the biggest requirement.
Yeah, what I'm saying, Francesco, is it's beyond that. So it's not just the location, it's also what the frequencies are, or if the cores can even handle the workload landing on it. So what I'm asking you is to consider that topology is one of many attributes we may care about with the CPUs. Kevin, am I making sense?
And
you're making sense in kind of the, the grander vision for how you would do better alignment. But I think Derek's question is just more about if we wanted to continue supporting this topology and where scheduling that's already in place that makes use of resources that are advertised by these existing components. How would we do that in this?
Or do we cease that work, or what would be, or is that work that people were tracking that we should inform this? It's far more or less grandiose. Like, I appreciate that with the sustainability efforts, there's more interesting power management issues that people can explore, and not making a value judgment in any way, shape, or form. Just kind of wondering, like,
I think
looking at this now.
I think what Mauro mentioned is still also interesting. The dynamic resource allocation is something which now becomes exposed to the scheduler. The question is if we can fulfill the topology requirements with other kind of mechanism, maybe through some extension of dynamic resource allocation and stuff like that. But yeah, it's also a question of performance. If we will hit the performance requirements, what you have with such kind of topology management, topology aware scheduling.
We have plans for how to support topology aware stuff in DRA, but it's very different than the topology aware scheduling stuff that's been going on until now based on these managers. So
another thought, I guess
I think for that separately from this, but go ahead.
Another thought to this was there ever anything explored around making just-in-time execution of these plugins being a preferred model versus a long-running pod running as a daemon set on a node that takes some CPU or memory budget? If you had a way to just-in-time launch this plugin and ask it this question and then sleep it again, is that ultimately preferred?
I mean, that's a good idea, but I think that has to do with your plugin implementation. So you could do your plugin in such a way that you're just calling a library and you have minimal resources as you run.
Yeah, this is why I was kind of asking, like, if daemon sets are intended to be the management model that these things are deployed at, because they don't need to be, right? And with a pod comes this sense of permanence, and particularly majority of the time they're not going to be doing anything, right? They're just going to be sitting there doing nothing. So I was curious if we had any appetite for maybe exploring a just-in-time type of invocation of the plugin and then, you know, shut down of the plugin.
Gotcha. So we're talking a gRPC interface. So I bet you could interface to anything you wanted. So if we want to start exploring other things outside daemon sets, that may be interesting, but it may be outside of what we can accomplish in the time for this.
Yeah, I think a little bit after having some ground on kind of, but yeah, it's interesting thing to be looked at, I think. Yeah.
Like, it's a great idea. I love it. I don't know if we're going to have the capacity for it. Will the gRPC be sufficient, I guess, is my question, to start exploring other models as well.
Yeah, it raises some other questions. If you have something like just in time, if those things are put to sleep, if they are moved around, see if you're not breaking other work. So it's complex kind of topic, right?
I was imagining some type of socket-based activation, and these plugins could be deployed into some directory, almost like CNI plugins, right? Not the whole daemon set, but just drop in some Etsy folder somewhere or some var folder somewhere. And do I need a long running pod is what I was just trying to think through. And I'm not saying yes or no either way, but I could see benefits of not needing it. So I was just curious if it was something that explored or not.
No, we haven't, but it would be interesting. You're still going to need, for some things like power management, for instance, you still need to monitor the cores. And so you're still going to need to be able to change the frequencies ad hoc. Because part of what's going on with our Kubernetes power manager is we're having to wait for the pull from the API server to know when the pod's set up, which is a little silly considering we just want the information of what's going on the node, right? So those will have to be long running, and those will fit nicely into this plugin model. But what you're talking about, where it's just at start and end, like, I think we should look at other things.
Yeah, typically device plugins tend to need to be long running too, because you know they do two things. They advertise the set of devices that are available, but then they also monitor the health of them and update that list over time if any device becomes unhealthy.
Yeah, so for things like the built-in resources, I was just trying to think through if that was really needed or not. I could see long running if there's some metric that they export that would be useful. It's just a thought on that. I get a lot of pushback from our users that there's too many out-of-the-box pods running on every node, and this would potentially expand that same list of out-of-the-box pods that some of our high-performance users get upset about. So just curious on people's perspectives.
Well, we're 2 minutes to the top of the hour. Do we want to continue discussing on Thursday? I know not everyone that could make Thursday can make today, but it looks like you all did. What do you think?
Yeah, I won't be able to make it Thursday, but obviously continue without me.
Yeah, I should be able to make it Thursday. I'm curious if there was much more to the deck.
Not too much. We had a little bit an illustration, basically how the gRPC site works, but this is nothing really huge. It's similar to device plugins mechanisms. You have a gRPC socket, basically, which is created by Kubelet, and then the daemon sets are registering against it. And the state machine actually is handled by the plugins. And yeah, they can be only read-only if you don't want to have privileges, root privileges in the plugins. We in that case, as we discussed, can come back to the runtime and do the allocations. Then we depend what the runtime supports. And in the other cases where plugins needs to do more, then you could have privileged kind of plugins, right?
Yeah. So I know we're at time. I'll be there on Thursday. I think just speaking for myself, and maybe others could help iterate to get here. I'm very open to us supporting a plugin ecosystem. What I want to make sure we do is don't, by virtue of doing that, make existing deployers' lives more complex for existing function. So
Absolutely, yeah, I got you.
if maybe some of the feedback that was given in today's discussion, which would be those who don't worry about error complexity with the distribution, maybe we can make some updates to the enhancement or get feedback on it that says maybe the built-in thing just stays built in and kubelet managed without necessarily kubelet extracted. Maybe if you all have time to think on that a little bit more, that'd be good. But I worry about the error complexity of people running things today as this rolls out. But I'm very open to, people innovating and doing new things here. So it was just, maybe we can find some marriage of those two tensions. That would be great.
Yep.
All right. All the best. I'll talk to you all on Thursday. Thanks for setting this up.
Bye, guys. Thanks.
Thank you.
Thank you. Bye.
Sergey, we'll figure out how to get,